All right, here we are with example number 1 for lesson 2, which is velocity. In this example, we start out with a toy plane. This toy plane is located 51 meters north of a city. It then proceeds to travel at a rate of 27 meters per second south for 3.90 seconds. So a couple things I noticed in this question right away. First off, they're being very specific about the number of sig figs, which means that we're probably going to want to start drilling the sig fig thing in here. In fact, I noticed that we have 3 sig figs in this problem. Let's turn our saturation there. So we have 3 sig figs. We're going to hold on to that to make sure we check that at the end. All right, so what do we have? We have a toy plane and it's located 51 meters north of a city. So let's say, we'll draw a little diagram here. We're going to have a city. I'll just make the city a dot. All right, this is going to be our city. Perfect. In this case, I think we're going to want to make, let's make north positive. Let's make north positive. So we have north, east, south, west, with north being positive, south being negative, because this is only traveling north and south. We don't have to worry about east and west. All right. And we are starting at a distance of, let's go blue, 51 meters to the north. There we are. And this is our starting distance. Okay. Right on. Now, this plane is going to travel 27 meters per second south for 3.9 seconds. Well, what do we know? Beginning of this topic, we get the formula for velocity, which we kind of messed around with a little bit in the last topic. We know that, where do I want to write this? Velocity is equal to displacement over time. Well, if we want to figure out the displacement, or even the distance for that matter, velocity times time is going to be what we want. We rearranged this in the last lesson in example number 1 of lesson number 1. So if you want to have a more thorough recap on this, you're welcome to go back. But essentially, I'm just multiplying both sides by the denominator. I'm going to cancel out these, and we're going to be left with the displacement is equal to velocity times time. All right. So now we want to figure out the displacement that this is going to travel in, was it 3.90 seconds. So I'm going to write those values down here. We're traveling, going to be traveling southbound. So from here, going to be traveling all the way down here, and we can say that this is, we have a velocity of 27.0 meters per second, and the time that this was traveling was 3.90 seconds. Well, let's just dump those in here, and let's figure out how far this plane actually traveled in that time. So our delta D is equal to 27.0 meters per second times 3.90 seconds. Great. Delta D, plug that into our calculator. I get a value of 105.3 meters. So 105.3 meters. Great. All right. Is that what it's asking? Not quite. No. All this is telling us is that this distance, I should really get a new color going here, is 105.3 meters. But it's asking us its final location. Well, let's give it our final location. It's probably asking our final location in reference to the city. So if we know that this thing is starting 51 meters north of the city, and we traveled 105 meters south, we should be able to figure out how far we're going here. Let's do this in magenta. All right, so if we started at a positive, 51.0 meters north of the city, it's going to be our positive value. And we are moving south, so we're not going to add the distance on here. We're actually going to pull that distance out. 105.3 meters, because south is our negative direction, right? So we have a negative value here. This is going to give us a negative value. This is going to give us negative 54.3 meters. Negative 54.3 meters. Well, it's negative 54.3 meters north. But if we flip the direction symbol, we can flip the positive negative symbol. So we're actually going to say that this value here is going to equal to 54.3 meters south. Let's box that. Good. Check our sig figs. Started with 3, ending with 3. This problem's done.